Welcome back. My name is Elias Sinkala. Don't forget to subscribe, comment, and also share. Let's go again, mathematical induction. So we're going 6B. Yeah, we've already finished 6A. So we're going 6B. Yeah. So the 6B is going to say 3n minus 1 is divisible by 2, right? Yeah, like what I've said, mathematical induction consists of three steps. So we'll go step 1. Step 1 always is let n is equal to 1 because no any assumption that has been given, no any condition that has been given. So this assumption you have to develop on your own. Therefore, we get the actual equation. It's 3 to the power n minus 1 is equal to whatever there is n, I put 1 minus 1, 3 minus 1, which is equal to what? 2. Right? And this case, this 2 can be divided by what? By that 2. This 2 is divisible by what? It is divisible by what? It is divisible by 2. The same 2 that have been given. So we say, therefore, it is true n is equal to what? 2. 1. Please note that each and every day, that's an assumption that you have to develop. N is equal to 1 if no condition had been given. So, here we go in step 2. Step 2, it's let n is equal to k. Always. Even if, in this step, even if you have been given an assumption, or let me say condition, at least it's a law. In fact, it's a principle. A law can be broken down. So what's going to happen is this. We get the same equation. It's 3 to the power n minus 1. Whatever this n, I put k minus 1. Then I have to put, in this case, it is quite different. It will be different with what we solved the previous question. In this case, I'm going to equate to what? What you have been given. Which is what? These 2. Right? Of which you say 3 to the power k minus 1 is equal to what? 2. And in this case, you can put 2 stand with any letter. For instance, we put 2r. Right? With such kind of question, if I have to make that kind of question, so here we go. We say 3 to the power k minus 1 is equal to 2r is equal to 3 to the power k minus 1. Sorry, is equal to. So what's going to happen here? This negative 1 has to cross equals and come this side so that we remain with 3 to the power k. Right? Always. So we say 2r, when this 1 comes this side to be what? Plus 1. And in this case, since we make 3 to the power k as a subject of formula, we can mark this one with a star. And that indicates to say you are coming back. And you're showing the marker to say, I'm coming back. Like what I've said, step 2, we do not conclude. The appearance of step 2, it's the purpose of step 3. So I say, I go in step 3. Then I say, let n is equal to k plus 1. Right? Then I get the same equation. I say 3 to the power n minus 1. Whatever there is k, n I put what? K plus 1 minus 1. Right? Now, if I have to take you back in indices, if I want to break down these ones, right? Oh, you agree with me if I like this. So 3k times 3 to the power 1. The multiplication also to say, if the base are the same, you can add the powers, of which you're going to, if I say 3 to the power k times 3 to the power 1, which is 3 to the power k plus 1, one and the same. Right? Minus 1. Now, not that we have created something as a subgroup of formula and have marked it in step 2, and I've created that to say we're coming back, which is this. So what I'm going to do, we say whatever is 3k, I put what? Or which if I put this 3 in front here, so I understand because I'm multiplying with this. So whatever is 3k, I put what? 2r plus 1 minus 1. That indicates to say, this 3 is multiplying with everything. What I've said, we do not conclude to the final number, but to show what is supposed to be done. We say 3, that's mathematical induction, times 2r plus 3 times 1 minus 1. So we're going to allow this first part to come down. So first of all, we undo this. So I say 3 times 2r plus, what is common here? It's 1. Then inside I'm going to remain with what? 3 minus what? 1. What is common here? It's 1, right? Then here to be 3 times 1, that is 3. Then minus this 1. So I say, please, these people here get confused. I'm doing 3 numbers here. 1, 2, 3, right? At the end of the day, I'll say, what is common here? It's 1, which is this one, right? Then here I have to get one number here. I'll say, the one that is common, if I have to divide with this, to divide with 1, then I say, then I'll remain with only 1 here. So I'll multiply this one, 3 times 1, that is 3, minus 1, which is this one. So I say, 3 times 2r plus 1, 3 minus 1, that is 2, of which we're going to remain with 2. Then I say 3 times 2r plus what? 1 times 2. Right? Now see, what is common also here is 2. So 2, I put it outside here. Then I'm going to remain with what? 3 times what? R, right? Plus. What is common here is what? What is common there? So here I'm going to remain with what is called, okay, so I'll do this. What is common here? It will be what? That is 2. Then here I'm remaining with what? 3 times what? Times R plus 1 times 1. Then I say 3 times R, that is 3R plus 1 times 1, that is 1. Of which 2 is divisible. 2 is divisible. So here I should to have the number that you have been given to say is divisible by, which is 2. So here you can conclude, you say therefore it is true n is equal to k plus 1, hence it is true, concluding just 1 mark, n is a member of natural numbers. Thank you very much. Stay blessed. Don't forget to subscribe, like, and also share, comment for encouragement. See you in the next video. Thank you.